this chapter, I will introduce 5 main technical points of the commissioning of SINAMICS S200 PTI and demonstrate operations in web server. The first technical point is the processing of pulse signals, starting with the electronic gear ratio setting for the PTI interface, which is the pulse input. If the gear ratio is an integer multiple, you can directly set the number of pulses per motor revolution by setting parameter P29271. If the gear ratio is not an integer, you can set P29271 to 0 and set the numerator in parameter P29272 and the denominator in parameter P29273. For the PTO interface, which handles pulse output, you can set the value of parameter P4408 to define the number of pulses output per motor revolution. If you want to set a non-integer multiple for the pulse output, set P4408 to 0, then configure the numerator in parameter P4410 and the denominator in parameter P4409. In order to reduce noise and enhance stability, pulse filtering is necessary. The SINAMICS S200 PTI uses a 2-stage averaging filter in series with a first-order filter to improve operational stability. As shown in the figure, averaging filter can effectively improve the smoothness of the position command. 2-stage averaging filter can reduce the jerk, thereby minimizing mechanical impact. The diagram below shows the pulse signal flow. First, the pulse input undergoes its gear ratio conversion, then passes through the filters, and finally reach the position set point. Optimization of gantry synchronization will be done through technical point 2 and technical point 3. Technical point 2 is introduced to estimate inertia via online tuning, as the both y-axis needs to ensure synchronized operation to avoid twisting of the machinery. Through the following steps, the estimation of the inertia and characteristics of the machinery can be done under the synchronized operation of the two axes. Set P5271 index 4 to 1, activate torque pre-control. Then set P5300 to 2, activate online tuning. At this point, the S200 has begun estimation the inertia, enable the system through the upper controller, and send position commands to make the gantry run back and forth until the value of the load inertia parameters P1498 converges and remains stable. Then set P5300 to 0 to end the online optimization. Finally, take the average of the load inertia values of the two y-axes and write it back to P1498. Technical point 3. I will explain how to use one-button tuning to system identification. Here, the system identification of the gantry is performed by performing one-button tuning, which is a step that only needs to be performed for one y-axis. First, set P5271 index 4 to 1 to enable torque pre-control. Then set P5301 index 2 to 0 to disable load inertia estimation. Next, set P5308 to 1 degree to limit the operating range and allow the drive to run shorter distance. Set P5300 to 1 to enable one-button tuning via the control panel. Then open the control panel of the web server. Take over the control, click on the jog, and start to execute the one-button tuning. After completing the optimization, copy the relevant parameters through a SD card, such as speed control gain, current set point filter, etc., and pass them to the other y-axis.